Hello, everybody. I'm Dimitrios Lignos. I'm professor here at TPFL. And I'd like today to explore, to navigate you through the RESSLab-hub through a demonstration example on how the component databases that we have put together can be explored. So I'm going to come here in the front page where you see that there is an interactive map that essentially tells you how the data we have collected so far has been distributed across the globe. And for instance, if I'm interested into searching on connections, you see that, for instance, if I go here in United States and I focus here in the area near Lehigh University, currently we've collected about 15 data points from there. And if I click in one of those, essentially you can see which one is this one. And if I click here, I can directly go into the actual report of the particular data point that I found. But if I want to collectively explore the data, then I would use the tabs here, where, for instance, I will go into connections, and you see that the connections come with the database setting, the component model, as well as fragility functions for connections. So I will show you today how you could potentially navigate the option of database. So if you click on the database, you see that the menu here comes with the data collection that at this point we have about 100 connections put together. Where there are some tabs here with information buttons where it can show you what each one of these tabs does. And for instance, if you know the researcher you are looking for, you can come here, and I can use, for instance, Professor Rickles from Lehigh University. I can see here what kind of data is available in this case. And for instance, if I click in one, I would get a single panel test view where basic information from this particular test would be available, including the reference source if you want more details. So if you are looking here in the tab, you click here the options, you see what kind of data is available in this case. And we have here decomposed the moment chord rotation for the beam. We have the full subassembly response, as well as the case where the panel zone inelastic shear distortion is actually available. If I go back to the original menu and I reset the filters, I can search my database with a different option. For instance, if I'm looking for a particular connection here, you can actually go through the connection type tab here. And for instance, if we are interested about reduced beam section connections, if I click this one, the data is going to be filtered, and I will only explore connections with reduced beam section. Also, if I'm interested about the particular date for testing, I can actually filter further the data. And eventually, if I am interested about connections with certain geometric characteristics, such as particular column depth or connections where I'm interested about composite action, I can, for instance, filter again the data, and I can see what is available. So for instance, here, if I click the option, this is a test from the SAC program in the US, conducted by Professor Mike Engerhard from University of Texas, Austin. You see that the data is fully digitized, decomposed into panel zone response, as well as subassembly response in this case. Again, you get the basic geometric information, including, in this case, information about the slab. And of course, if I click on the source file, it will directly point me to the website where you could essentially download this particular report. Now, I'd like to show you also a couple of things related to visualization aspects that we have created. For instance, in recent years, we've been exploring the influence of panel zones into structural response. Obviously, we would like to see the data collectively, and in particular, we would like to see what kind of data is available for, say, certain panel zone shear distortions. So I can use here the parallel axis plot, where I can filter the data into connections that give me inelastic panel zone shear distortions between, say, 10 gamma y to something like 30 gamma y, or you can define any other range of interest. I could be looking also into cases where my column flange is actually thick being, above 2 inches or above 50 millimeters. And also I could be focusing into, say, beam depths that are of particular depth, let's say about 1 meter or about 900 millimeters. And I can even screen further by looking into particular connections. For instance, I could be looking again at reduced beam sections. So if I apply the selection, the data is screened again accordingly, and then I get the corresponding data points that have these type of characteristics. Last thing, with regards to the navigation tool, I'd like to show you how you can actually download data into your computer. So if we assume that, you do some sort of selection where you are interested about, say, RBS connections or connections with, say, other characteristics, and you apply the selection. And then out of those, you want to look at, very particular connection types, such as welded flange, welded web. And then out of those, you would like, say, to filter into connections that were tested after 2008. You see here that there are about 15 tests or so that are available. And if you select here the ones that you would like to actually download, and you hit download, the database here is going to ask you what kind of data you would like to download. And the data is composed of master data, which is going to be tabulated in a spreadsheet, versus also test data, which is going to be the actual digitized histories that could be informative if, for instance, you are working on constitutive models and you would like this data to be used for validation purposes. So if I click confirm, you see here that the data is downloaded into my computer, and then in a zip format. And then if you unzip, essentially you should have the data available. Now, I'd like to take also a few moments to show you a little bit the other aspects of the connection tab. So here, as I said, you have the option to go through a component model where we have been developing over the last 15 to 20 years assessment models for different structural elements. And for each of these assessment models, you can find the actual reference if you want to explore or if you want to read about more details. But the point is that, these assessment models require input parameters related to geometry as well as material properties. And eventually, through regression equations, you can actually get the actual force deformation relationship that you need to use in a structural analysis model to conduct nonlinear analysis. So in this case, where we talk about connections, the menu here works by selecting a still profile from the American, European, or Japanese cross-sections that are available. So I will show you this with the American cross-sections. I can pick a particular type of connection here that I may be interested. I will, for instance, for illustration purposes, use, say, a W24 by 103 profile. And then here, where I have beams with RBS, beams without RBS, I get a basic backbone that essentially refers to beams with reduced beam section or beams without reduced beam section. You can get the monotonic backbone in case you have an adaptive backbone model, such as the modified Ibarra-Medina-Cravinkler model. And in that case, you could conduct nonlinear response history analysis. Or if you're doing a nonlinear static analysis in line with ASE 41 or Eurocode 8 Part 3, you could be using the component model that refers here to the first cycle envelope, and you could conduct your analysis. Now, if you have beams with different geometric characteristics, you can essentially change the corresponding length of your beam. Or if you have, let's say, cases where, for instance, I'm going to set my beam here to about 7 meters. If you have cases where the actual yield strength, for instance, is high yield strength steel or low yield strength steel, let's say, you can adapt the menu, including also, the corresponding bracing length, lateral bracing length. Or if your reduced beam section is not maxed out on the flanges, but you're using, let's say, 25% reduction in the flanges, again, the component model is interactive and is going to be able to provide you the actual information. Moreover, all the values here for the anchor points of the component model come tabulated, and you can basically use them directly into any structural analysis software you may be using. Finally, if you are working into performance-based earthquake engineering with emphasis into fragility analysis, risk analysis, or loss estimation, you could be using, the tab on fragility curves, where, again, we have developed different types of fragility curve families for connections, specifically pre-Northridge connections, as well as post-Northridge connections. You could select between different steel types for pre-Northridge connections, for instance, where low yield strength steel was popular at that time. And of course, you could, in certain cases, you could explore how fragility curves will be influenced by, for instance, geometric properties of your beam, such as the beam length or the actual beam depth. Similarly, we have done the same for columns. And the layout is actually quite similar, as well as braces, structural steel materials that we've tested here at EPFL considerably over the last 8 years, as well as other types of information, such as residual stresses, that generally could be useful for finite element calibration and further development. So I'd like to thank you very much for your kind attention. And if you have any questions, you could consider contacting our team directly from the information button here on the very right. That essentially shows you who are the people who have been extensively involved into this type of development.